Hello, I'm Seth, and today we're going to make a frequency distribution, and we're going to do this in Excel. So what you can see here is we have several different scores. It doesn't really matter what the variable is, although it does kind of matter whether it's discrete or continuous. Let's say to start, we'll say these are discrete data. So I've gone ahead and made all of the columns for our frequency distribution. The score is just going to be all the possible categories, all the rows that we'll have in the distribution. If you need to figure out your highest and lowest scores, you can highlight all of the cells and then click this sort and filter option and say go from smallest to largest. And you can see the smallest is 1 and the largest is 10. Okay, so in the score column, I'm going to start with 1, and the next will be 2. And I'm going to start from the bottom just because that's a little easier for people to visualize. You don't have to write all of the values out. Once you have a pattern happening, highlight those 2 cells, grab the bottom right corner, and drag it up. And you can see Excel can figure out what you're doing, and it will continue. It will continue the pattern. So I'll drag it all the way up to 10. There we go. The F stands for frequency, and in that column, we're simply going to count the number of times that each score occurred in the distribution. So for example, you can see there's only one value of 1, so that's going to be a 1 right there. The score of 1 has a frequency of 1 because it only occurred 1 time. Looks like 2 is going to have a frequency of 3 because that occurred 3 times. Now, you can count these manually, but sometimes you're going to be dealing with very large data sets where that's not really convenient. So you could write a formula to count it for you. To do that, let's say this is equal to. Something to know about Excel is you can't just start writing a formula. You need to start with an equal sign in the cell because that signals it that you're not just writing information or data, you're trying to make it do something. So we'll say count if. This function just counts the number of cells in some range that meet whatever criteria you specify. So we want to count the cells that are equal to 1. All right, so we can say equals count if. Now you could just sort of highlight all of these with your mouse. If you're on Windows, you can use Control-Shift down to highlight them all. And anyway, so that is our range. Count if anything in that range, comma, is equal to 1. Okay? There's only 1 that meets that specification, which we already knew that was going to be the answer. Now, if I try to grab the bottom right corner and drag this up, I'm going to run into problems. So whenever I drag from the 11th row to the 10th row, you can see it also moved the range of scores along with it. The range was supposed to be down here, but it got dragged up because it's trying to follow what I want. So if you need any range of cells to stay locked in place in a formula, you can use dollar signs. So in my original formula, I'm going to put a dollar sign before the 2 and before the 21. This range means from A2 through A21. And I'm just kind of locking that into place. What this will do is it makes it so now when I drag it up, it keeps counting this range from A2 to A21. It's holding those cells, so that can be useful. Now, if I dragged in another direction, like to the right, notice it keeps the 2 through 21 because that's what I locked in place with those dollar signs, but I didn't lock the letters in place. So now whenever I drag to the right, it moves over into the B column. If I wanted it to lock the column as well, you could just put dollar signs there as well. Now, if I drag it around, it still continues to be that range, A2 to A21. So this partially does what I want, but then you may notice I'm getting frequencies of 1 for every score, which we know is wrong. We know there's supposed to be 3 scores of 2. And the problem is, in my formula, I'm copying. When you're dragging, you're really just copying the formula along. And so what's happening is it's checking how many scores of 1 there are in that range. So it's doing the same thing over and over and over. Now, there may be a faster way to do this, but I like to just manually update them. So this formula needs to update so that we're counting the number of 2s that occur. All right. This formula needs to update so we're counting the number of 3s, and so on. Like I said, I'm sure there's some speedier way to do this, but I don't know it, and this way doesn't really take that much time. Okay, so let's just check and see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that's doing what I want. One way to check our work is to make sure that the total of the frequency column is the same as the total number of scores. So the total number of scores I'm going to represent with an N for number, I guess. So first, let's just check and see what this should be. I'm going to say count how many values there are right here. There are 20. Now I'm going to use equals sum. This formula will add up whatever you throw into it. So I'm going to say sum all those frequencies. It comes out to 20. So these match as expected, which means we've probably done this column correctly. So the CF stands for cumulative frequency. Cumulative just means building, and that's exactly what this column does. This column tells us how many scores are at or below our current row. So in this first case, there's just 1 score there. So we can just say 1 score is at or below a score of 1. So how many scores are at or below a score of 2? Well, you could say 3 plus 1 is 4. Or you could say, I have 1 so far, and I'm going to add 3 to it. Both ways will work. So let's first say sum of 3 and 1. Sorry, you can't really see that. There we go. It's a little still hard to see. But anyway, I'm just highlighting the 2 cells. So 3 and 1 sum to 4. Now, that's fine, but it will actually be a little more convenient to say this is equal to this D10 cell, D10, plus the cell right below. So what this formula says is take whatever my cumulative frequency is so far and then add the frequency for the next row. What I like about this is it will conveniently scale up like this. You can just grab the bottom right corner. You can just grab the bottom right corner and drag it up. So first we had a single score, then we added 3 more, which brought us to 4. We added 3 more, which brought us to 7, added 4 more, which brought us to 11. So it's just how many scores are at or below this score. And at the end, the final answer is 20. All 20 scores are at or below 10, which we already knew because 10 is the highest number. So once again, we can check and confirm that we've done this correctly. The cumulative frequency is the same as the sample size. The next column is P, which stands for proportion. A proportion is equal to the part divided by the whole. And in this case, we're going to be dividing each individual frequency by the total frequency. So for example, 1 divided by 20 is 0.05. Remember that proportions range from 0 to 1, and they represent the amount of the total that a particular score is accounting for. If we multiply that by 100, we get the percentage. So 5%. What this means is that 5% of the scores in this distribution are equal to 1. 1 out of the 20 scores is a score of 1. We can't drag this. We're going to run into the same problems as before, where when we just drag it up, it not only moves the numerator, but it's also moving the denominator. It's trying to be helpful, and it's not doing what we want. So in this original formula, we're going to lock the 13 in place. That's going to keep us on the 13th row, which it keeps this value as the denominator. Now I can drag up, and let's see if it's doing what we want. Yep, it's dividing 4 by 20. That's exactly what we want. And that's equal to 0.2. So we can drag that all the way up. A quick way to check whether we've done this correctly is to add up all the proportions. Remember, each proportion is the part divided by the whole. That means all of the parts have to add up to the whole. So let's sum them. Okay, they come up to 1, which is a very good sign, because remember, proportions range from 0 to 1. And when we take all the parts together, they add up to 1. Now, the more familiar version of this for many people is the percentage, where all we're doing is taking that proportion and multiplying it times 100. So whereas proportions are how many parts out of 1, a percentage is how many parts out of 100. So we can just drag this up. Notice this is continuing to do exactly what we want. This is going to be equal to whatever is to the left times 100. So 0.1 becomes 10%. So we can drag that all the way up. Now, what would this add up to if we've done this correctly? All the parts have to add up to 100, because it's how many parts out of 100. So add all the parts together, the total is 100. Now this C% sign stands for cumulative percentage. This comes in quite handy because it will give us what's called a percentile. So we use the exact same logic as we used in the cumulative frequency column. First of all, the first is just equal to 5. What this is saying is 5% of scores are at or below a score of 1. And that makes sense because, there's only one score there out of 20, and that's 5%. Now, like before, we can say for the score of 2, it's equal to 5% plus 15%, which is 20%. And this is the same as if we would have just added like this. Okay, we can copy that up. And to make sure it's doing what we want, let's check in on one of them. Okay, this cell, it's saying we have a 55% cumulative, cumulative percentage of 55, and then we're adding 5 more, and that gives us 60. And this would have been the same as if we would have added up all of them like this, but that's just a little bit more of a pain. This way allows me to just copy it all the way up. Okay, so like before, we wanted the cumulative frequency to be 20. Similarly, we want the cumulative percentage to be 100. All of the percentages individually should add up to 100%. If you're doing this by hand, you might get something like 100.1 or 99.9%. That's just due to rounding error. It's not a big deal. Now, as I said, the cumulative percentage also gives us the percentile. So how we could interpret this is we could say 60% of scores are at or below a score of 5. That just means 60% of the distribution is in this range from 1 to 5. Expectedly, 100% of the scores are at or below 10 because 10 is the highest value. Okay, so that's a basic rundown of how to create a frequency distribution when you have discrete data where each score, like maybe these are number of kittens in your home, so there's just integers numbers. There's not like 2.7. But when you have continuous data, you're probably going to want to use a grouped frequency distribution. So with a grouped frequency distribution, you're sort of just creating buckets or bins, and these are called class intervals, and these are like ranges of scores. So let's say our first range is 1 to 2, and our second is 3 to 4, 5 to 6, 7 to 8, and then 9 to 10. So now what we're doing is we're saying, well, what is the frequency of scores that fall within the range of 1 to 2? And what fall within the range of 3 to 4? And let's also make the data look a little more continuous. Say we've got like 3.99, 4.1. So just some more precise values. Okay, so for this first group, we want to know how many scores fall within the range 1 to 2. And if you've watched the video on real limits, you'll know it's really anything from 0.5 to 2.49 because of rounding. Like this score of 2.23, we're going to throw that in the 1 to 2 bucket because that's closer to a 2 than it is to a 3. So one way we could do this is we could just manually count. We could say 1, 2, 3, 4 scores fall in that range. And then let's see, 1, 2, 3, 4, 5, 6, 7 scores fall in that range. But formulas can be more convenient sometimes. So I can write a formula that says equals count if S, so ifs plural. That means I'm going to give it multiple conditions to count on. So first we're going to say for A2 to A21, that's the range of our scores. And then we say comma, what criteria? And we're going to say if it is greater than or equal to 0.5. Okay, and I'm putting this in quotation marks just because that's how Excel likes it. And you might think, wait a minute, there are no scores smaller than 1, so why even bother? Well, because you may be dealing with data sets where you have a score of like 0.75 and you would like that to round to 1. So approaching it in this way will make sure that you get what you want. So this says count the number of scores in this range that are greater than or equal to 0.5 because those would round to a 1. Comma, it's going to ask for the range again, which it's the same. You can highlight the cells again, or you could type them A2 through A21, comma, and then our second criteria is that they are less than 2.5 because 2.5 and above, that's going to round up to 3. That goes into a different bin. Okay, so how many scores meet those criteria? 4 of them do. There are 4 scores between 0.5 and 2.5. So those are the scores that would get rounded to 1 or 2 and thrown into this bucket. Okay, so we can do something similar. Let's say COUNTIF. Now I've just memorized, it's A2 to A21. If it is greater than or equal to 2.5 and the value in that range is less than 4.5, because that would be bordering on our next bucket, which is 5 to 6. Okay, let's check to make sure that's working correctly. There should be 1, 2, 3, 4, 5, 6, 7, and we got them all. Okay, so now we're going to say count if scores in this range are greater than or equal to 4.5, and if scores in this range are less than 6.5, because 6.5 and above, that's going to round into this. Okay, I've made an error. I used the count if function, and whenever I tried to enter it, hopefully it's showing the error message. It says there are too many arguments for this function. That's because I should have been using the count ifs, plural, which can accommodate multiple conditions like this. All right, now it's working. Let's double check and make sure 5 to 6. 1, 2, 3. Yep, that worked correctly. Our next bucket should have 3. So this time I'm going to do it correctly. Count if if it's what are we looking at? 7 to 8. So if it's greater than or equal to 6.5, and if it's less than 8.5, because 8.5 and above would round into our next bucket. Okay, last one. Anything in that range that is, well, okay, so now that we're at this point, we can simplify our work a little bit. We could just say, hold on, I want you to count if there's anything that is larger or greater than or equal to 8.5, because anything above that goes into that bucket. Similarly, we could have done something like that down here for this first bucket. We could have just said, wait, just count if there's anything that is less than 2.5, because that would round down into this bucket. Doesn't really matter, same answer. Okay, let's check and make sure everything's working the way it's supposed to. I'm just going to redo these. All right, so our sample size is 20, so our frequency should be 20, which they are. So 4 scores fall into this bucket, 7 fall into this bucket, and so on. All right, and we can use the same approach that we've used before to get our cumulative frequencies. So here, what this means, for example, is that 17 scores are at or below this bucket, 7 to 8. And technically, that would mean anything from 8.49 downward. Because remember, even a score of like 8.3 is going to get rounded into this bucket. The proportions are the same as before. It's the part divided by the whole. So this bucket accounts for 4 out of 20 scores. That's 0.2. Let's lock that 20 into place by saying always reference the 8th row. Then we can drag this up. These will add up to 1. Multiply the proportions times percentages. Copy them whatever way makes you happy. Add them up to 100. Notice once you've got a formula, you don't really have to like retype it again. I can just say copy whatever is happening here and do it in this column as well. So here it was adding up all of those. So if it's doing it in this column as well, it's adding up all of those. And they add to 100. All right, and then the approach that we used for the cumulative frequency will work for the cumulative percentage. 20% of scores are at or below this first class interval of 1 to 2. Then it's going to be 55 because we have 20, and then we've added another 35%. Okay, and now we can just copy up this formula, and it adds up to 100 as we knew it would. And that's how you create a grouped frequency distribution, which is more useful when you've got a lot of scores and when you've got continuous data. And I think that is it. Oh, I guess one thing I can say real quick is if you wanted to interpret these as percentiles, just remember, if these are discrete data, you would be able to say 70% of scores are at or below a score of 6. But if these were continuous, then more precisely, you would say 70% of scores are at or below a score of 6.49, really, because even a score of 6.49, that would be rounded into this bucket. And so that's the level of precision we can speak at when using a percentile in this context. Okay, that is it. If you have questions about creating frequency distributions or grouped frequency distributions, let me know.